There are some important angles for which you need to memorize the x and y coordinates of the point pxy that corresponds to these angles. There's no way around it. In order to take calculus and be successful, you really need to memorize all of these. Okay? So I'm going to do my best to help you understand and memorize these. The first point is here at 0, I'm sorry, not 0, at 1, 0. Yeah? If you had an angle whose terminal and initial side were both lying on the x-axis, that would be an angle of, hold on, I'm going to move the p, of 0 degrees, or 0 radians. Let me move this too. 0 radians. But it could also be the same thing as 2 pi radians. So this p is 1, 0. Okay? Why do you need to memorize these? Well, they're going to give you the sine and cosine values of all of these angles. And these are very, very common angles that come up again and again and again. Remember that x is the cosine and y is the sine. Okay. The next one that's very important is up here, and its point is 0, 1. Yeah? It is the angle pi over 2 radians, or the same thing as 90 degrees. Remember that the entire one way all the way around the circle is 2 pi. So around half the circle is pi radians, and so half of that at the fourth is pi over 2. That brings us to our third one, which is pi radians, or 180 degrees. P here is negative 0, 1. I'm sorry, negative 1, 0. Negative 0. How funny. Okay. The third one, the fourth one, probably, pardon, that you need to know is this one here, right? It's 3 pi over 2 radians, or what you might call, in degrees, 270 degrees. And the p that corresponds to this is 0, has coordinates 0, negative 1. Notice that if you start over here at 0 and count this way, you go pi over 2, pi, which is the same thing. So you go pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is the same thing as 2 pi. Okay. Now some other ones that are really important to know. Yeah? The first set are the ones that lie here, right? So again, we're talking about an angle in standard position whose terminal side lands at the point here, P, with coordinates square root of 2 over 2 and square root of 2 over 2. What is the measurement of this angle? Well, in degrees it's 45 degrees, but in radians it's half of pi over 2. So it's pi over 4 degrees, or pi over 2 radians, or 45 degrees. I'm going to get rid of the angle itself. Alright. Why is it square root of 2 over 2 and square root of 2 over 2? Yeah? Well, that has everything to do with the fact of the Pythagorean theorem. In fact, all of the trig values of these angles that we're going to be looking at, all of the x's and y's of the p's, where the terminal side intersects the unit circle, are going to be proven by the Pythagorean theorem. So I'm just going to show you one for this particular pi over 4, and it should give you an idea of how we came up with the other ones. Ah, my goodness. So we're just going to zoom in here. Here's part of our unit circle. This is the x-axis and the y-axis, and I'm going to draw, we're going to say that this is 45 degrees, or pi over 4. And since this is the unit circle, I know that this length here is 1. Now, because this triangle has pi over 4 degrees, this right triangle that I'm drawing has pi over 4 degrees in this angle, it also has pi over 4 degrees in this angle. So what that means is that this is a 45, 45, 90 triangle. Right? And what that means then is that that the x and y here, remember I'm looking for a point, I'm looking for an x and y. The x here, let's call it x, and the y here, let's call it y. They are equivalent to each other. Yeah. So let's use the Pythagorean theorem. We know that we would get x squared plus y squared equals 1 squared. But since they're equal to each other, let's use x to be both of them. We end up with 2x squared equals 1. That's the same thing as x squared equals 1/2. And when I take the square root of 1/2 and rationalize the denominator, I get plus or minus the square root of 2 over 2. And since this point is happening in the first quadrant, I know that its x coordinates and its y coordinates are both positive. So we get square root of 2 over 2 and square root of 2 over 2. Alright, let's continue. The next angle that's 45 degrees from pi over 4 is pi over 2. We've already talked about that. So now let's go to the next angle that's 45 degrees from pi over 2. Which angle is it? Well, if we go here, that's pi over 4. Here we go 2 pi over 4. Here we can go 3 pi over 4. So we're going to call this 3 pi over 4 radians. And it's the same thing as 90 plus 45 degrees, or 135 degrees. Okay? Now, notice that it's at the same y height as pi over 4's, p, so it's going to have square root of 2 over 2 as its y-coordinate, but it's directly symmetric across the y-axis, so it's going to have almost the same x-coordinate, except that it's going to be negative. So we get negative square root of 2 over 2. Alright, down here we get, this is 5 pi over 4 radians, or the same thing as 225 degrees. Its p is going to be, both negative square root of 2 over 2, negative square root of 2 over 2, and if we went to 3 pi over 4, that'd be 3 pi over 2 would be 6 pi over 4. That makes this one 7 pi over 4, which is the same thing as 315 degrees, 45 plus 270. Its p, its point, the x and y coordinates are square root of 2 over 2 and negative square root of 2 over 2. Okay, so again, these you need to memorize. I attached a file, just a reminder, I attached a file under document sharing on WebAssign of a blank unit circle. Looks just like the one here that's blank. You should be following along with me and filling in all these values as we go. And then use it as a sheet to do your work, but try to memorize it as you go. Alright, some more angles. Let's look at a couple more angles. Yeah. The next set, I'm going to do in a different color. Let's do green. Look what happens if I take this and separate as such. I'm separating the circle into 6 pieces. 1, 2, 3, 4, 5, 6. So I get these angles. Remember that from 0 to 180 is pi radians, right? From 0 degrees to 180 degrees is pi radians. So if I'm separating pi, or the upper half of the circle, into 3, this angle here will be pi divided by 3. This one will be 2 pi divided by 3, making pi 3 pi over 3. Then we're going to get 4 pi over 3 and 5 pi over 3 down here. Of course, 6 pi over 3. Close, 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 please. I guess that's this one. Ah! Oh no. Okay, we're back. 6 pi over 3 ends up being over here 6 pi over 3, which is the same thing as 2 pi, right? Okay, what are the p values here? The x and y values of p here, I should say. Turns out that p here is, the x coordinate is 1/2. The y coordinate is square root of 3 over 2. Here we get almost the same, except the x coordinate is negative square root of 3 over 2. 4 pi over 3 here is going to have x coordinate negative 1/2 and negative root 3 over 2, since both would be negative. And for 5 pi over 3, we're going to get positive 1/2, but this time the y coordinate will be negative because we're in quadrant 4. All right. All right, we have one more set of angles that are important to know about, and those are the pi over 6 angles. I just realized that I forgot to put the degree measurements on these angles. Notice pi over 3 now is 60 degrees, 2 pi over 3 120, 4 pi over 3 is 240, and 5 pi over 3 is 300. Okay, one more set of angles. These are the pi over 6s. Pi over 6 is the same thing as 30 degrees. Again, we're separating the entire top semicircle, the whole top semicircle, half of the circle, into 6 parts to get pi over 6, because it's all pi divided by 6 is pi over 6. And that's the same as 30 degrees. Now it's interesting, the p, x and y values here for the corresponding point to pi over 6 are the opposite of the pi over 3. Pi over 3, if you look back really quick, was 1/2 comma square root of 3 over 2. Here, that's square root of 3 over 2 comma 1/2. Okay? Now, if we go forward another pi over 6 or 30 degrees, that makes us land at 2 pi over 6, which reduces to pi over 3, which is 60 degrees. We already talked about the coordinates of that up in the above picture. We go forward another pi over 6, that's 3 pi over 6, or pi over 2, which we've already talked about. 4 pi over 6 is 2 pi over 3, and the next one is 5 pi over 6. Alright, so we're going to again just make the x coordinate negative, y is positive. Down here at 7 pi over 6, we're going to get negative square root of 3 over 2 and negative 1/2. And over here at 11 pi over 6, which is the last pi over 6 angle, we get a positive square root of 3 over 2, but a negative 1/2 this time. So again, you need to memorize these values, all of these values that we just drove. All of the pi over 6s, all of the pi over 3 angles, all of the pi over 4 angles, and then the 4 what we call quadrangles, I think. The ones that are at the on the axes. Okay, you should draw them all in one coordinate plane, label them all, and work on it. When you're doing your work, use it at first, but then start to try to draw it from memory if you can. The more often you do that, the less you'll need to rely on that. And again, it is really, really, really important. Okay, so we're going to use that information that we just discovered to find the exact value of a few different things. I'll probably run out of time in this video to do both of the ones I want to do. So let's just do 3 cosecant of pi over 3 plus the cotangent of pi over 4. So how do we use these x and y values, right? Well, let's start with cosecant of pi over 3. So for pi over 3, we know that the p, x, y, and y values is 1/2 square root of 3 over 2. So since cosecant of pi over 3 is 1 over the y value by definition, then we're going to take 1 over the square root of 3 over 2, which is the same thing as 2 over root 3. Again, rationalizing that denominator, we get 2 root 3 over 3. Okay. Now, for pi over 4, we have p is square root of 2 over 2 and square root of 2 over 2. So by definition, cotangent of pi over 4 is x over y. So that means we're going to take 1/2 divided by square root of 3 over 2. I'm sorry, pardon me, it's not 1/2, it's square root of 2 over... let me pause it. Sorry about that. Square root of 2 over 2 and square root over 2 over 2, which is 1. So then 3 cosecant pi over 3 plus cotangent pi over 4, plugging it in, we get 3 times 2 root 3 over 3 plus 1 The 3's cancel, and we have 2 root 3 plus 1.